Okay, thank you very much for the opportunities. Let me introduce myself. My name is Putu Wijaya Sunu from Bali State Polytechnic, and I would like to deliver my presentation entitled Preliminary Study of Solar PV Characteristic Cooled by Water Spray. Okay, let's start my presentation with a perspective from the world energy history. From the world energy history, in the beginning of development in industrial, the coal, oil, and natural gas playing an important role. But now in the recent decade, the modern renewable energy become more popular, such as solar PV, and uh, this the prediction of the solar PV in 2040 become the a dominant electrical supply for domestic and industrial application. And we can say that the solar energy is the rising star. Okay, let's see the trend of energy in Indonesia. In Indonesia, electrical energy plays an important role for the domestic and industrial application, and others energy like gas, liquid fuel, and bioenergy, and also involved in the industrial. But we can see from the right figure that uh, in 2050, the renewable energy, especially for solar energy, will very dominant in the application. And this data is based on Indonesia Energy Outlook. Let's continue with the experimental setup. Based on previous study literature, that the surface temperature of the PV strongly affected the power produced by the PV itself. So our research tried to cool the PV surface with the water spraying technique. The water pumped through the pipe system by a centrifugal pump. A 10 nozzle were placed on the edge of the solar PV, which is spraying the water to the surface of solar PV. And the solar PV was cooled during the optimum irradiation, about 1000 watt per meter square of a day period, 2.5 hours. And the technical specification of our PV funnel, you can see on the right table in this slide. Okay, let's see our result. The data were conducted under relatively high radiation intensities at noon. It's about 1000 watt per meter square. This increase of PV surface temperature was logged under the solar irradiation without any cooling system in the left figure. We can see the temperature was about almost 51 centigrade, and the data was then compared to that of the surface temperature, the solar PV about 33 centigrade in the right figure. And the water flow rates was considered 4 liters per minute for all PV surface area. Okay, let's see the next figure. In this figure, we can see the comparison without cooling, the surface without cooling, and the surface PV surface with cooling by the water spray, and maintain the temperature 33 centigrade. We can see in the voltage, and the PV with cooling and maintain the temperature about 33 centigrade have a voltage higher than the PV without cooling. And this phenomena also revealed in the current. And so in these two electrical parameter affected to the power, and we can see the power of the uh, PV with the cooling surface is higher than the PV without cooling. You can see in the in this figure. Okay, for the last part of our presentation, this is the conclusion uh, in our research. The first, the application of cooling system by means of a separate cooling is very possible, especially for tropical country. And the second, based on the concerned operating condition, the average power per cool PV surface is about 107 watt and 94 watt for non-cool PV. It has strong correlation between the output electrical energy and the surface PV temperature. Okay, thank you very much for the time.